Hi guys, I hope you're good since last video. So in this video we're going to talk about an amazing tool, Langfuse, which is going to help you to trace LLM calls. I'll explain you the scenario a little bit later on, but for the moment I'm going to talk about Chikara Houses, this website sponsoring our video. So you can here show different products in your social media and get rewarded, which is interesting. And also you can have access to the different AI tools if you have access to the GPT store of OpenAI. So get your social media community know about Chikara Houses collections and get rewarded. So it's on the non-affiliate products that you like, and your followers, you just show it and they'll be able to purchase and you get a percentage of it. It's a third party taking care of that, and they also have the GPTs available. You just tap Chikara into the GPT store and you get access to all those GPTs. Alright, so local Postgres 16 configs. We're going to just go through different precision in different configurations that you need to do, because you're going to be running Langfuse in Docker and it's going to be using Postgres. So if you have a local Postgres in your server, I suggest you to add here this configuration, listen address, and you provide it just the little star here to say that you can listen to any address to be able to use your RAG in parallel. Or you can use your server IP. So you can also put the server IP. Just to show you quickly how to install pgvector, sudo apt install Postgres 16. So you will need Postgres 16 with pgvector activated in order for it to work. You might get also an issue with Ollama, because here I'm running it as a front process. And they have hard-coded Yamato into the library. So what we're gonna do, what I suggest you to do, is to not bother, just change the model straight away into the library and put the model that you want to use. For the Ollama embeddings, I'm gonna use Mistral 7B. So on the top here you can see the path will be in your virtual environment in Langchain community library, and inside the embeddings ollama.py. And here you can see at the top you have Yamato. This is hard-coded, but I suggest you to use your embedding model, the one that you want to use. So me, I'm using Mistral 7B. So we're just gonna copy this, comment out the original line, and put our own. Just get rid of Yamato here. Okay. This is just for you to understand that you need Postgres 16 with pgvector activated. And you need the server Postgres to be able to listen to any address. So here we start Ollama. I've downloaded Mistral 7B. I'm just going to run it. So the embedding will be ready. I have a script. I have a folder with some documents. I'm going to embed. So here we see that it's running. We got the first API call when the model have been loaded. So you launch your docs, embeddings, your process, embed all your documents. So here the process is going to start. Just going to have, this is the unit break, please like and subscribe. While coding, I'm listening to some Japanese music, so feel free to do the same. So here, what is the scenario? we're going to be just project yourself that you have LLMs, you have your users using it, you have your internal employees using it, and you want to have control on what's going on behind. So you want to see all the prompts, all the answers, and you can put a special server, allocate a server for that, and for your security team to be able to see what's behind, and also for the cost and the improvements that you wanna implement. So here is Langfuse. I did some traces a few days before using the RAG, the retrieval. It was another document about capital cities around the world. So here you can see what is the capital of Senegal. It is Dakar. On the right side, you get all the nested functions, and it shows you the chain that has been used. So you can see here the details of the prompts, and here you get the models, the paid ones. So I'm not using paid model, that's why there's no cost in the traces. Here it knows that is a chat Olyama that we're using. As you can see here, we can see the system prompt also. So you can have an overview of what's going on with all the calls, the sessions, which users are using it, and so on. At this time you can enforce your internal policies and make sure that it's used in a safe way. So the embeddings are running, that's the previous document. Just took a while, but we can see how the chunks are formatted. So document, page content. If you watched some past videos, you already know about that. But for the people who haven't seen before, so the chunks are going to be getting part of the sentences, the documents. They're not all the same size, but they're trying to be the same size that we determine in the code. This is a paper about language acquisition. So example of the doc that we used in the example of the traces. This is cities around the world. You see here Turkmenistan, this is capital, and as always first Afghanistan, Zinzabad, Afghanistan. Quick code details, just for you to know how to trace. It's very easy to implement, so that's why I'm suggesting you to use this open source software, this open source project. So we have the decorator, observe, and the callback handler. That's the two I'm using the most. So for the decorator here, so here observe, observation. For example, here it's a function chat with Grok. So I put the decorator on the top of it, and it's going to do the job. We have the quarks. And here, Langfuse context is another decorator. Update that current observations. We got the input and the metadata, which is coming from the keyword arguments. And after we have the system prompt and everything. And here the chain that we do with the prompt. And here down there, you see I put another decorator because this function is calling the one on the top. So what is interesting is that if you have nested functions, that's why I wanted to show you that, it will be tracing all the flow of nested functions. So this is the text that we use as argument. Here, keyword arguments, human message. Okay, that's the one coming here. And that's why we define, we put as an argument text equal question. And here we call the chat with Grok function with the other one. So that's why you got this kind of cascade traces. And I'm going to show you another way to do the tracing by using a callback handler. So for sure at the beginning you need to initialize the Langfuse secret key, public key, and the host, the IP, which is a localhost 3000 normally, and the callback handler. So same for Langfuse handler. And using that with the longchain function and chaining, here for example for the retriever, that's the one I used. That's the one that you've seen the 2 traces. So here you can use the function. It works with invoke, the invoke function, but with some other functions also. Which function? Let's just write invoke. So it works with .invoke, .predict, .run, and something else. There's one more, but I forgot it. But you can check the documentation. It's all coming from the documentation. I'll just check if I can find it somewhere in my comments. But no, I haven't put it in the comments. So we are in the documentation. So here, what you're gonna do, you're gonna invoke the database using a query, and in the configs, you're gonna here reference the Langfuse handler, the one that we have defined on the top. Okay, so now you know everything in how to trace your LLM calls. So I suggest you to use this open source software, Langfuse. It's very easy to implement. You see, it's just using decorators and just setting up the environment. I didn't show you how to install it and everything because it's just Docker Compose up basically. You just clone the repository. Maybe I'll do a video about it later on if you need to see how to install it. Alright, I hope that you like this video and see you next time.